Welcome back, guys. It's Certified Genius, and today we're going to be going over slope-intercept form. In the last video, I went over what slope was, how to find slope in two different ways, and I think I touched base with a formula called standard form on how to find slope, but today we're going to be doing a much simpler version of that. We're also going to be interpreting slope in real-life situations, so that way you can have a better understanding. For new visitors to my channel, make sure you subscribe and turn on that post notifications and like this video. For returning subscribers, sit back, enjoy. Now, with that being said, let's get into the video. So a lot of people are probably asking, what is slope-intercept form? And it is an equation, y equals mx plus b. M is our slope, which, you know, is the steepness of a hill. Not of a hill, I apologize. Of the line on the graph. Our x-coordinate, which is an x-coordinate of the points x and y. And b, which is our y-intercept. And a y-intercept is where our line on our graph intersects with the y-axis. For example, if I had an equation of y equals 2x plus 5, I know that 2 is my slope because it takes the place of m. And, you know, x stays there because it's an x-coordinate. And then my 5 is my y-intercept, which means that in a real-life situation, that's going to be my initial value. And when I say initial value, that's the value we're going to begin with before we go up or down with our constant rate of change, which is our slope. So now, since you have like a little understanding of y equals mx plus b, I'm going to give you a real-life example of how y equals mx plus b is used. So the graph on this paper shows that a tree is growing at a constant rate of change over time. When the time, it's just 1 year and the height measurement is in feet. So on the graph, or according to the graph, my y-intercept is 2. So that means that 2 feet, which you know is our measurement of height, is our initial value. And then we're going to go up to here. Well, how did we get up to there? How many feet did our tree grow from 2 feet? So since we're doing this like a change over time, we're going to the year 1991. And if we go up to our point, it's at 4 feet. Okay, well, I know that I started off at 2. So how do I get from 2 to 4? Well, that's just plus 2. And you could see, like, you have to check if your line follows this constant rate the entire time. So if we go to the second year, 1992, we're going to go up, and it's grown 6 feet now. Okay, well, it's at 6 feet. How did it get from 4 to 6? Plus 2. And if you were to keep going, you could see this pattern all through the line. And that would mean that our slope, or our constant rate of change, is 2. That means that y equals 2x, because if you were to plug in any of these x coordinates, you know, depending on what problem you're doing, you would get an answer of what y equals, but, you know, it's a whole thing. So we got y equals 2x. Now we have to find our y-intercept. Well, where does the line start? What unit does it start at? Where does it interact on the y-axis? Our line in this case interacts with the number 2. We started off at number 2 in the year 1990. Then as the years went on, we just kept going up 2. So then I know that my y-intercept is 2. So that means that our equation is y equals 2x plus 2. So then you could also do this in an algebraic way. For trying to find slope in an algebraic way, change over y over change over x. That's how you find slope in an algebraic way. Change over y over change over x. When you say change, in this case, it really means subtraction. So if you're given like 2 coordinates, you could use this method. y2 minus y1 over x2 minus x1. This formula right here is used to find slope. And since it's used to find slope, we use it algebraically, or you could just use like a simpler version and do rise over run. So if we're given the points, let's see, we can treat these years as like basic units like 1 and 2. 1990 is our origin, which the origin of a graph is 0. And then we could keep going 1, 2, 3, 4, 5 because the years are just going up by 1. So let's say at 1991, I'm given 1 and then 4. That means that our points are 1 and 4. And for another pair of coordinates, I'm giving 1992 and 6. That means that in 1992, the tree grew 6 feet. Or it just is 6 feet and it grew 2 because our constant rate of change is 2. So we have 2 and then 6. So I'm given 2 points, 1 and then 4, which we could say 1991 and then 4. And then we're given 2 and then 6, which we could say 1992 and then 6. So then the formula that I showed you for slope is when this comes into play. You could, when it says y2 minus y1 over x2 minus x1, you label these points any way that you want to because the subtraction just is going to work anyway. So x1, y1, x2, y2. So this is the way that I ordered my pairs. x1, y1, x2, y2. So now I have 6 because our equation, our formula for slope states y2 minus y1 over x2 minus x1. So 6 minus 4 over 2 minus 1. Well, then we just work out the subtraction, and we end up getting 2 over 1, which equals 2. So this, it tells me that my slope is equal to 2, which you also could have found out by doing rise over run, but sometimes a test or homework assignment asks you to do it the algebraic way, and you have to do it that way. So we know that my slope is 2. And now we have to find my y-intercept. There's a way that you can do this, and it's by simply using the method of plugging in your numbers. So if we follow the y equals mx plus b, well, I know that my m, which is my slope, is 2. So I just put y equals 2x plus b. But you can also substitute coordinates from your graph into this equation. So where it says y equals, we would put in the y coordinate. And then where it says x next to the slope, you could put an x coordinate. So if I had the coordinate 1 and 4, I meant to say, we could do 4, which is my y coordinate, equals 2, my slope, times my x coordinate, which is 1, plus b, because we don't know our y-intercept, and that's what we're trying to solve for. So if we were to simplify this equation, 4 would equal 2 plus b. And if our point is to isolate the variable in this equation, which is b, we want to get rid of any of the terms that's next to it. In this case, the b and the 2 are connected by addition. So I would subtract 2 from both sides because I want my equation to be equal. So that leaves me with b equals 4 minus 2, which is 2. This proves that my y-intercept is 2. To check this, you would just put it back in, so plug 2 back into the equation. So then that means that 4 equals 2 times 1 plus 2. And the reason I'm plugging in these numbers is to just check my work, where the 4 is one of my y coordinates from my graph, and the x, my 1, is one of my x coordinates from the graph. And then 2 is our slope, and we also established that 2 is our y-intercept. So if we were to check this, that means that if we were to do this equation, that means it would equal 4 in the end. So that means that 4 equals 2 plus 2, and 4 equals 4. Check. So that means that now I can settle my equation and find my answer. Y equals 2x plus 2. The algebraic method is hard sometimes, and you could get confused if you miss a negative or something like that. So you really do need to take your time when doing these types of equations. All equations you should take your time for. So, and also double check your work, because you never know what you could have missed. And like one misstep could cause a whole chaos of wrong answers. So yeah. In conclusion, this video was about what y equals mx plus b was, where y is our line and our m is our slope, our x is an x coordinate, and our b is our y intercept. Interpreting these like numbers or our slope intercept form in real life would mean that m, which is our slope, is our constant rate of change, and our y intercept is our initial value, which is where we start before we go on with the constant rate of change. This was the end of the video, guys. Hope you enjoyed it as much as I did. I will be posting another video this weekend. This would be on functions and how they work, which it really isn't that complicated. And yeah, I will see you guys another time. And remember to stay cool, stay weird, and love math. Goodbye, guys.